Okay, students, can we name each of these substances and identify the charge of their cations and anions? I hope so. Let's take a look at just a few of them. Beginning with this one. We can begin by saying that the element K, potassium, is in column 1 of the periodic table. Because it's in column 1 of the periodic table, when it's in an ionic compound, it can only exist as having one charge, which is a +1. You can't have a potassium +2 or +3 or something ridiculous like that. So the cation charge is obviously going to be +1. What about the anion? What is the anion in this thing? Well, the anion is SO4. That's one of those polyatomic anions that I've required you, my students, to memorize. The name of that anion is sulfate. So I'm going to go ahead and write down sulfate here. And its charge is -2. That hopefully makes sense as to why we have to have two potassiums here, each having a +1 charge in order to counterbalance the -2 charge from the sulfate. So I've got potassium here as a cation. I have sulfate as an anion, so the full name of this is potassium sulfate. And I don't have enough room to write that in one line, so I'm going to put it into two. Normally I would put it into one line. So potassium sulfate +1 -2. Very good. Let's go ahead and scroll down through these, and I'll see if I can pick a slightly harder one. Let's look at this one here. I've got Fe, which is iron, and then I've got this NO3 thing. Fe, I'll go ahead and write down iron in its name. Now iron is not in column 1 or 2 of the periodic table. Therefore, it can potentially exist as having multiple different charges in different ionic compounds depending on what the charge is of the anion to which it is bonded. So I'm going to have to put Roman numerals to indicate whatever the charge of this particular iron has to be. How do I figure out what that charge is? Well, I do that by looking at the charge of the anion. So that anion, NO3, is one of the polyatomic anions whose names and charges I've required you to memorize. That anion is called nitrate. Now I'm going to go ahead and write it down here because I'm running out of, or I don't have enough room to do it in one line. But it's iron something nitrate. What is the charge of nitrate? Well, once again, I've required you, my students, to memorize that nitrate has a charge of -1. So the anion over here has a charge of -1. You'll notice that there are two of them. Each of those nitrates has a charge of -1, and there are two of them, each one stuck to a different side of this iron atom. So I've got iron stuck to two nitrates. Each one has a charge of -1, which means that iron must have a charge of +2, because it has to have a +2 charge to counterbalance the total -2 charge of two individual nitrates that each have a -1 charge. Okay, hopefully you're okay with that. And because that cation of iron is going to have a +2 charge, in the name I will go ahead and throw down a Roman numeral 2. So the final name of this is going to be iron, Roman numeral 2, nitrate. Now that distinguishes it from iron 3 nitrate, for example, because that can totally exist as well. At least potentially you could have iron 3 nitrate, which you'd have 3 nitrates bound to that iron, because iron, once again, is one of those elements that is not in column 1 or 2 of the periodic table. I'll let you go ahead and tackle the rest of these on your own.